Okay, so should we start or we should wait for 2 more minutes? Others to join. Am I audible to you?
Yes, sir. Yes, sir.
Yes, sir. Okay, so should we start or we should wait for 2 more minutes? Others to join. I think already.
Sir, others are coming, sir. Let them join first.
Okay. So let's wait for 2-3 more minutes. So meanwhile others to join. So let us recall what we have done in last class. So let us start share my screen. So I hope a blank screen is visible to all of you. Is it like that?
No, sir.
No? ये हमारे को
Sir, visible है.
Okay. So can you recall what we have done in last class? I think 2 notes I have given for you to verify. Can you recall them?
Yes, sir. Remark, to remark.
Not 2 remarks or note whatever it is. First, I think I have given you is that the inclusion map from A to X is continuous. And the second remark or note I have given is let A from X to Y be a continuous map. Just wait, someone is trying to join. Then F restricted to A from A to Y is continuous. Of course, where A is subset of X. So this you already know. A restriction of a continuous map is continuous, and inclusion map is continuous. And also I have given one more line. In subspace topology on A is the smallest topology such that these inclusion maps are continuous maps. So I hope you have already done it. Okay, so now we have to continue in continuation of that. Those who wish to join may join on time. Just wait 1 minute. So the notes which I am going to explain here, so you just concentrate on that. And so on daily basis, whatever I will discuss, I will share with you. Okay, so I hope one or two students which are in my contact. So if I will share with them, then everybody will get. Is it like that?
Yes, sir.
Okay. 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 So I think this is the if as you were saying that in last class I have given two remark and have asked you to explain. So these explanation I have already written here. Why the subspace topology is the smallest topology, so that this inclusion map is continuous. Okay. So for that, what I am saying that let I from A to X be this inclusion map. Okay. So why first of all that this inclusion map is continuous? Because if a map is continuous, if the inverse image of open set is open. So now here we have considered I inverse of U. So I inverse of U will be what? U intersection A. Is it all right? This equality? अगर I inclusion map है और UX का subset है, तो जब उसका inverse image निकालेंगे तो क्या होगा? That is nothing but the intersection of A, and U intersection A belongs to tau A. What is this tau A? Tau A is basically the subspace topology on A, and which belongs to tau A. So that's why this inclusion map is continuous. Okay. Now my claim is that this tau A is the smallest topology such that this inclusion map is continuous. So suppose it is not like that, or let us take tau 1 is tau 1. Is there any another topology on A for which this inclusion map is continuous map? I mean here I from A to X we have taken continuous map. Now A is equipped with some another topology different from this subspace topology, and that topology we have given the name this tau 1. Okay, so now since this inclusion map is continuous, then are you convinced that this tau A is contained in tau 1? क्योंकि अगर ये inclusion map continuous है, तो इस क्या होगा? Inverse image of open set is open. अगर आप U कोई भी open subset X का लेते हैं, तो जो उसका inverse image है, I inverse of U, that is U intersection A, वो क्या होगा? वो A में open होना चाहिए. A में open होगा, इसका मतलब क्या होगा? वो tau A में belong करेगा. So that means all such subset U intersection A belongs to tau 1. Why? Because this inclusion map is continuous map under this topology. So that's why we are saying that tau A is contained in tau 1. Okay, and in this way we can say that this subspace topology is the smallest topology such that this inclusion map is continuous. Is this explanation is all right?
Yes, sir.
Okay, you just say yes or no, then I will know that whether I have to continue or I have to explain. और ये जो दूसरी वाली थी ये तो easy है. Why the restriction of continuous map is continuous? Because this restriction map, if restricted to A from A to I, this can be treated as the composition of two continuous maps, I from A to X and A from X to I. Okay, let us compose these two maps. ये inclusion map है और ये the given map है. तो जब आप इस I और F को compose करेंगे, then what you will get? You will get F restricted to A from A to Y. Okay, and we earlier we have seen that the composition of two continuous maps are continuous. So that's why this composition F composed with I. F composed with I is what? That is nothing but F restricted to A. And this is continuous. Why? Because I have already written. This is continuous because it is a composition of two continuous maps. Okay. Now next we are going to discuss a glue lemma. So this is a very important result of this topology course. Okay, so here I would like to explain in rough first, then I would like to. So these rough notes I will also share with you, and that fair notes I will also share with you. So you just need to concentrate here what I am discussing, and if you have doubt, you can ask. Okay. So what this glue lemma says, is that we have been given this a topological space X top. Further, we are saying that this AI we have been given a family of subsets of X, some indexing set, and all these AIs are subset of X. Further, here we are assuming that all these AIs are open or closed. Okay, या तो सारे open है या सारे closed है. I hope this is like that. Yes. Then what we have been given कि जो आपका X है, so that is nothing but the union of these AIs. And also one important thing is that here indexing set we have taken finite. I mean this I consists of 1, 2, 3 up to n. Or you can say that if 1 is less than I is less than equal to n. A finite collection we have taken whose union is whole of a space X. This is the first one. Now basically our target is to define a map from X to Y, a continuous map. A continuous map we have to define. But we have been given the continuous maps from these subsets of X. I mean we have been given, what is given? We have been given Fi, a map from AI to Y. For every I we have been given. Okay. And further we have been given the restriction of Fi on AI intersection AJ are same. Are you getting what is the meaning of this second condition? I mean suppose I and J we have two maps, AI to Y. Further Fj we have another map, AJ to Y. So if their intersection is, if AI intersection AJ is phi, then no need to bother. Okay. But suppose AI intersection AJ is not equal to phi. So in that situation, we can consider the restriction of these maps Fi and Fj to AI intersection AJ, जो हमने यहाँ पे ले रखा है. What is this? The restriction of Fi to AI intersection AJ. Because AI intersection, if it is non-empty, then it is a subset of AI. And similarly, we can restrict Fj to the same map. Then these two maps should be same. These two maps should be same. This is our condition. Okay, so all these Fi are continuous maps we have been given. Second one is that their union is equal to whole of X. And if for some AI and AJ, if their intersection is non-empty, and if we restrict to their intersection, then these two maps should be equal. Okay. Then what this glue lemma says, if we define a map from X to Y by F restricted to AI is equal to Fi for every I, then F is a continuous. Then F is a continuous. So first of all, are you getting how this map is defined? हमें क्या given था? We were given Fi's from AI to Y. Now we have to define a map A from X to Y. But how it is given? How we have to define? And if you recall that also we have been given that X is equal to union of AI. So basically we have defined map like that. F of X is equal to Fi of X for some X. Sorry, for some I. And under this definition, we have to prove that if this map is continuous map, then F is a continuous map. Look, two things you have to understood here. How this map is defined, and second one is that whether this mapping is well defined or not. Okay. Because look, if we have to define a map from X to Y, then what we need? Simply we need the image of every point in X. But here we have been given that X is equal to union of AI. अगर आप X कोई भी एलिमेंट X में लेंगे और X union of AI is है, what does it mean? It means that X belongs to AI for some I. X belongs to AI for some I. I will request you that those who wish to join, please join on time. If you don't want to join, then it's also yours. But if you want to attend, then please join on time. Okay. So now in this way, so now every X in X will belongs to AI for some I. So here fx is equal to what? Fi x we are defining. This is our definition. Because for every AI, these maps we have been given. This f we have not been given. But these fi's we have been given. So since x belonging to AI and fi is a map from AI to y, so whatever be the image of x under this fi, so that we will take the image of x under f. Now, who will explain that this mapping is well defined? And first of all, is that why we need to check that this mapping is well defined? इसकी जरूरत क्यों है? क्योंकि it is possible that here x belonging to x, then x is equal to union of a. So it is also possible that the same x may belong to some aj also. So under this definition, what we will get? अगर हम x को aj में लेते हैं तो fx की में इसको हम fj x assume करेंगे, और अगर x को ai में लेते हैं तो fx की वैल्यू को हम fi x assume करेंगे. So unless this fi x is equal to fj x, unless these two are same, we cannot say that this mapping is well defined. So that's why we need to check here that this mapping is well defined. So who will explain that why this mapping is well defined? Yes.
सर वो जो सेकेंड कंडीशन हमने ली थी शायद.
बिल्कुल. ये जो सेकंड कंडीशन हमने नहीं लिखा है कि fi restricted to a1 into ai intersection aj is equal to fj restricted to ai intersection aj. तो अगर आपका x ai और aj दोनों में है, इसका मतलब क्या हुआ कि वो इंटरसेक्शन में है, और जब भी इंटरसेक्शन में है इसका मतलब ये दोनों मैप सेम है रिस्ट्रिक्शन पे. इसका मतलब क्या हुआ कि जो fi x है वो इज इक्वल टू fj x है ड्यू टू दैट सेकंड कंडीशन. सो दैट्स व्हाई दिस मैपिंग इज वेल डिफाइंड. So here we have a well-defined map from x to y with the help of the maps which is given from ai to y. अब हमें इस f की कंटिन्यूटी प्रूव करनी है, तो वो सिंपल है. कंटिन्यूटी प्रूव करने के लिए हम क्या प्रूव करेंगे? ये प्रूव कर देंगे कि इनवर्स इमेज ऑफ ओपन सेट इज ओपन या इनवर्स इमेज ऑफ क्लोज सेट इज क्लोज. Okay, so now let us come back to these notes. Okay, so what I was saying, so the same thing has been written here. Okay, कि हमें फाइनाइट कलेक्शन एंड या तो हम सारे को ओपन मान रहे हैं, क्लोज मान रहे हैं, और उनका यूनियन x के इक्वल है, ये हमने अज्यूम कर लिया. और हमें गिवन है दिस fi's maps we have been given ai to y and all are continuous maps and satisfying this condition fi restricted to ai intersection aj is equal to this thing. So the meaning of this condition कि if we define then the function f from x to y defined by f restricted to ai is equal to fi x is a continuous map. So the reason for this condition is that this is a well defined map. अगर हमें ये कंडीशन नहीं गिवन होएगा तो ये मैप well defined नहीं होएगा. So this is required. Okay, so let us see. ये जो फार्मूला गिवन है हमने fx is equal to fi x से डिफाइन कर दिया. अब इसकी कंटिन्यूटी प्रूव करने के लिए हम क्या प्रूव करेंगे कि इनवर्स इमेज ऑफ क्लोज सेट इज क्लोज। तो हमने यहाँ पे तो वैसे इन जनरल दिखा दिया कि अगर f x से y में मैप है और f इस तरीके से डिफाइंड है, तो अगर हम f कोई भी सबसेट लेते हैं y का, तो जो f इनवर्स ऑफ f होगा दैट विल नथिंग बट द यूनियन ऑफ fi इनवर्स ऑफ f I varying from 1, that is for any subset, so in particular for closed subset. और यहाँ पे एंड वन मोर थिंग इज दैट व्हाई वी हैव टेकन कि हमने इनवर्स इमेज ऑफ क्लोज सेट इज क्लोज दिखाने जा रहे हैं, बिकॉज यहाँ पे हम एज्यूम कर रहे हैं कि ये सारे एआई इज क्लोज है। अगर ये सारे एआई ओपन हम लेके चलेंगे हाइपोथेसिस में, देन वी ट्राई टू प्रूव कि इनवर्स इमेज ऑफ ओपन सेट इज ओपन। क्योंकि एआई को हम क्लोज ले रहे हैं इसलिए हमने एफ ही कोई भी क्लोज सबसेट ले लिया। तो ये जो इक्वालिटी हमने लिखी है कि एफ इनवर्स ऑफ एफ विल बी यूनियन ऑफ एफ आई इनवर्स ऑफ एफ आई वेरिंग फ्रॉम 1 to n, सो दैट इक्वालिटी आई हैव आल्सो प्रूव्ड हियर। सो इट इज नॉट डिफिकल्ट। ओके, हमने x कोई भी हमने दोनों तरफ से इकट्ठा दिखा दिया कि अगर x कोई भी एलिमेंट f इनवर्स f में ले लिया, इसका मतलब क्या है? इसका मतलब ये है कि fx f में बिलोंग करेगा। अच्छा, fx f में बिलोंग करेगा तो fx क्या है? fx इज नथिंग बट fix फॉर सम i। तो अगर fix f में इसका मतलब क्या होगा कि x बिलोंग्स टू fi इनवर्स ऑफ f फॉर सम i। इसका मतलब क्या होगा कि x बिलोंग्स टू यूनियन ऑफ fi इनवर्स ऑफ fi वेरिंग फ्रॉम 1 to n। और अगेन we have in this direction, अगर x is union में इसका मतलब क्या होगा कि x belongs to fi inverse of f for some i। इसका मतलब कि fix belongs to f for some i। तो जो fix है वही तो fx है, fx belongs to f, so that means x belongs to f inverse of f। तो another way containment आ जाएगा और ऐसे this containment, so finally we get this equality। but here our target is to prove कि जो f inverse of f है वो x में closed है, क्योंकि हमें उस f from x to y को कंटीन्यूअस दिखाना है ना। इनवर्स इमेज ऑफ क्लोज सेट इज क्लोज। सो नाउ लेट अस ट्राई टू यूज इट। तो लेट अस सी हाउ। तो ये जो fi इनवर्स ऑफ f है दैट इज क्लोज्ड इन ai। भाई ये जो fi इज गिवन है ai से y में, ये सारे कंटीन्यूअस मैप्स हैं। तो इनवर्स इमेज ऑफ क्लोज सेट इज क्लोज क्योंकि f को हमने क्लोज सबसेट ले रखा है y में। ओके, and since this f inverse of f is closed in ai, then why this will be closed in x as well? Because ai is closed in x। अब यहाँ पे ai x में closed है, वो इंफॉर्मेशन हमने यूज कर लिया। कैन यू रिकॉल दैट कि ये जो हमने किया था ना कि अगर हमारा a f में कंटेंट है, सॉरी a सपोज कर लो कि b में कंटेंट है, b x में कंटेंट है। अगर a b में क्लोज है और b x में क्लोज है तो a will be closed in x। कैन यू रिकॉल दैट रिजल्ट?
Yes, sir.
Yes, you can recall that। तो ये जो fi इनवर्स ऑफ f ai में क्लोज्ड है, ai x में क्लोज्ड है, तो जो fi इनवर्स f है वो आपका x में क्लोज्ड हो गया। and that is true for every i, that is true for every i। so that means what कि this union, finite union will be closed in x। why? because finite union of closed set is closed। और ये जो finite union है ये f इनवर्स f के इक्वल अभी ऊपर दिखाया, so इसलिए f इनवर्स f is closed in x। so that's why this is continuous है। Why? Because we have proved that कि inverse image of closed set is closed। और अगर सारे AIs को हम ओपन लेके चलेंगे तो क्या करेंगे? बस इसी f को हम u ले लेंगे और u को ओपन मान लेंगे, बाकी all the analysis will be as it is। अच्छा, now can I ask one question कि ये जो स्टेटमेंट है इसके जो हाइपोथेसिस में हमने जो फाइनाइट कलेक्शन ले रखा है, अगर हम इसको आर्बिट्ररी कलेक्शन ले लेंगे तो क्या ये स्टेटमेंट ट्रू होगा? Instead of taking I varying from 1 to n, let us consider an infinite collection, and again let us assume everything as it is कि वो जो x है वो infinite collections का यूनियन है, वो इंटरसेक्शन पे दोनों मैप सेम है, we have defined a map on same pattern, and still we wish to check whether this map is continuous or not। Is this statement will be true?
सर नहीं ना, जब हमने नीचे यूज किया है दैट आर्बिट्री यूनियन ऑफ क्लोज सेट इज क्लोज्ड, वो आर्बिट्री यूनियन ऑफ क्लोज सेट तो क्लोज होता ही नहीं है ना, तो वो स्टेप पे हम फेल हो जाएंगे अगर एआई क्लोज्ड लेंगे तो।
अच्छा, और अगर ओपन ले लेंगे तो?
ओपन ले लेंगे तब तो हो जाएगा ना, बिकॉज आर्बिट्री यूनियन ऑफ ओपन सेट्स ओपन होता है।
वेरी गुड, वेरी गुड। सो इसका मतलब वी कैन मॉडिफाई दिस लेमा। क्या अगर हम एआई को क्लोज के बजाय अगर हम ओपन ले रहे हैं तो it doesn't matter if we have taken finite collection or arbitrary collection. But if we are taking closed, then this collection must be finite. Okay. So what I have asked, so this is exactly I have written as a remark or as a lemma. Okay. So what I have written is the above lemma can be extended for any family of open sets. But the above lemma is not true for an infinite family of closed sets. The reason what you told. Okay. Now one more question I would like to ask. Here the heading of this lemma is gluing lemma or pasting lemma. तो ये आपको सेंस आ रहा है कि हम इसको gluing lemma या pasting lemma क्यों कह रहे हैं? ये नाम क्यों दिया? gluing और pasting का मतलब तो आपको पता है ना जो डिक्शनरी मीनिंग है. तो why we are going to call this as a gluing lemma? क्योंकि yes, can you even try to attempt to explain it? Okay. So look, in the hypothesis, basically we have been these continuous maps we have been given. ये जो fi ai to y है, ये जो continuous map है that we have been given, and with the help of these maps we are going to define another map from x to y where x is the union of these ai's. तो हम कर क्या रहे हैं कि जो हमारा जो ai's पे जो continuous map है इन्हीं को आपस में glue करके और combine करके हम whole space x पे एक continuous map construct कर रहे हैं. So that's why we are going to call this as a gluing lemma, because this map is defined by gluing all these subsets ai's. क्योंकि इन सबका union क्या है आपका x के equal है. That's why we are in position to define a map from x to y. I hope it is all right.
Yes, sir.
Okay. Okay. So now in this note, what you people told कि अगर हम arbitrary जो है अगर हम closed ले लें तो वो कोई जरूरी नहीं कि continuous होएगा. Okay. But here I'm going to give you another hypothesis such that कि अगर हमारा arbitrary collection of closed sets है तब हमें एक continuous map कैसे मिलेगा. Okay. So for that, if we are going to impose a condition on this collection, suppose we have been given an arbitrary collection of closed sets, and we are going to define impose a condition on that. So under that condition, that might be this continuous map. Okay. So here we are going to define this locally finite or neighborhood finite. Okay. So what this definition says? A family AI of subsets of a space X is locally finite. Okay. Here we have taken a collection of subsets of X, a topological space X. So now what we are going to call? We are going to call this as a locally finite or neighborhood finite. दोनों का मतलब same है. If for each point of X has a neighborhood U, such that U intersection AI is not equal to 5 for at most finitely many indices I. I mean, for every X belongs to X, there exists an open NVD U of X. ये U जो है वो only finitely many को ही intersect करे, सबको ना intersect करे. U intersection AI is not equal to 5 for at most finitely many indices. So can you think quickly a collection of subsets which is locally finite and a collection of subsets which is not locally finite? Suppose let us take X is equal to R with usual topology. Suppose we have taken X is equal to R, and tau we have taken this usual topology. Okay. So if we define AI 0, I, so can you say that whether this is a locally finite collection or not? What is the definition of locally finite? कि for every x belonging to x, there exists open NBD U of x, such that this U intersects at most finitely many a's. So under this definition, can we say that this is locally finite?
Yes. Yes.
Yes, sir. कैसे?
एक पर्टिकुलर नेचुरल नंबर के बाद से इंटरसेक्शन एम्प्टी हो जाएगा. अगर कोई रियल नंबर ले रहे हैं x,
सपोज कर लो हमने x is equal to 2 ले लिया. अब 2 के अराउंड ऐसा कोई नेबरहुड बता सकते हैं जो केवल फाइनाइटली मेनी को इंटरसेक्ट करे?
नहीं होगा सर.
हाँ नहीं होगा. वेरी गुड. तो दिस इज नॉट लोकली फाइनाइट. क्योंकि आप ये देखो ना, ai क्या है, 0, i है, मतलब 0 to 1, 0 to 2, 0 to 3. तो एक बार कहीं भी आ गया तो सबको इंटरसेक्ट करेगा. लेकिन अगर हम ai को ऐसे डिफाइन कर ले, i, i plus 1, so is it locally finite? Yes. So here a neighborhood will always intersect only finitely many. क्योंकि अगर आप here what we have there exist, तो आप और कुछ नहीं तो कोई भी पॉइंट लेते हैं तो उसके अराउंड जो है आप एक स्मॉल रेडियस लेस देन 1 का ले लो. Whatever real number we have chosen, x is equal to a. So simply let us do like that. A minus 1 and a plus 1. ये open. So this type of open interval will intersect at most 1 or 2 AIs of this AI, because here this is a open interval of length at most 2. ये maximum 2 को intersect करेगा, 2 से ज़्यादा नहीं करेगा.
Yes sir.
Yes. So this is a locally finite family. So I have just tried to give you flavor कि कब locally finite होगा और कब locally finite नहीं होगा. Okay, so
सर एक बार ऊपर वाला बता दीजिए.
Okay. तो ये ऊपर वाले में आपका what are these AIs? What is your A1? A1 is 0, 1 closed interval. What is your A2? 0, 2 and like that. So in fact here we have nested one. A1 is contained in A2, is contained in A3, is contained in A4, like that. अगर आप कोई भी नेबरहुड लेते हो, अगर वो किसी भी AI में चला गया तो उसके बाद वाले सब में जाएगा. Suppose whatever be the open NBD U of x we have taken, and suppose this U intersect any one of these AIs, तो एक बार जिस AI को intersect कर दिया वो आगे सबको करेगा. Is it right?
Yes sir.
क्योंकि वो पूरा का पूरा कंटेनमेंट है हमारे पास. ठीक है. So that's why the above one is not locally.
सर डेफिनेशन वाला पेज एक बार.
बिल्कुल बिल्कुल. जस्ट मुझे भी आई है. This I will share with you. Don't worry. So here what said? A family we have taken, a subset of X, of a space X. Okay, is locally finite or neighborhood finite. What is the condition? If for each point of X has a neighborhood, there exists a neighborhood U, is such that this U intersects at most finitely many AIs. ये जो family है. Okay. Now next we are going to prove a very important statement, a proposition. अगर हमारे पास कोई भी locally finite family given है, if we have been given a collection of subsets which is locally finite. Okay. Then union AI closure is closed. Then union AI closure is closed. Okay. So let us see how we are going to do that. Okay. So here AI we have taken I belonging to some indexing set J. अब यहाँ पे ये नहीं कि this is finite or infinite. If this collection is finite, then there is no meaning of taking locally finite. Are you getting this one? अगर ऊपर वाले में finite collection है तो ये statement triply true है क्यों?
finite union तो closed ही होता है.
Finite union of closed set is closed. So that's why this locally finite, or even if in the definition, if this is a finite collection, even then this statement has no meaning. फिर तो जब ये collection ही finite है तो वो infinite को कहाँ से intersect करेगा? फिर तो वो करेगा ही करेगा. So every finite collection is always locally finite. No need to bother. So ये जो definition है इनके meaning तब है जब हमारे पास arbitrary collection है. Okay. तो अब हमें ये दिखाना है कि अगर AI जो है वो locally finite collection है तो हमें दिखाना है कि union AI closure जो है वो closed होगा. Because here we have considered the arbitrary union of closed set. तो arbitrary union of closed set मतलब इस set को closed दिखाने के लिए हमें क्या दिखाना पड़ेगा कि उसका complement open है. तो पहले तो हमने ये assume कर लिया कि हमारा indexing set J है. Okay. And we have to prove that कि ये जो हमारा union AI closure है I bearing over J is closed. So to prove that कि this is closed, we prove that कि its complement is open. तो हमने कोई भी एक पॉइंट कॉम्प्लीमेंट में ले लिया तो कॉम्प्लीमेंट को ओपन दिखाने के लिए हम कैसे दिखाएंगे? जो बेसिक डेफिनेशन क्या है? अगर किसी भी टोपोलॉजिकल स्पेस में किसी भी सेट को हमें ओपन दिखाना है, अगर हम करें कि ए कोई भी और हमें ए को ओपन दिखाना है तो हमें कि for every x belonging to A there exists an open belongs to U and U is contained in A, then we can say that A is open. So here we have to prove that कि this union AI closure is closed. इसको close दिखाने के लिए हम क्या देंगे? इसका complement open है. तो हमने complement के कोई भी point x ले लिया और at the end और what we will try to construct हमें दिखा दें कि basically V is an open set containing x. So what we are trying to prove कि x belonging to V and V is contained in this collection. Union AI closure I belongs to J complement. So that's why this is open and that's why union AI closure is closed. So in this way we are going to explain. So main our target is to construct this V. Okay, so let us see. Okay, so x हमने कोई भी एलिमेंट ले लिया इसमें union AI closure complement. इसका मतलब है x minus union AI closure I belongs to J. Look, now what is given? We have been given कि ये जो फैमिली है वो locally finite है. अब locally finite की क्या डेफिनेशन है? अगर हम x का कोई भी पॉइंट लेते हैं तो हमें एक ऐसा ओपन NPT U मिलेगा जो कि केवल फाइनाइटली मेनी को इंटरसेक्ट करेगा. So there exists an open set U of x जो कि only at most finitely many को इंटरसेक्ट कर रहा है. तो मान लिया कि वो इंडेक्सिंग सेट I है हमारा जिन फाइनाइटली मेनी को इंटरसेक्ट कर रहा है. I mean U1 to 3 up to n कर रहा है इसमें. We have just applied the definition. Now are you convinced with this slide? कि हमारा अगर U intersection AI not equal to phi है, so that will also give you कि U intersection AI closure is not equal to phi for every value of I belongs to I. ये जिस finite collection के लिए ये non empty है, उसी finite collection की हम बात कर रहे हैं. Is it right? रीजन हमने लिखा भी है parenthesis में. चूंकि AI closure में contained है, तो जो AI intersection UI होगा, वो इसमें contained होगा U intersection AI closure में. और चूंकि ये not equal to phi है इसलिए ये भी not equal to phi होगा. Is it right?
Yes, sir.
Okay. So now, but this is not equal to phi only for this indexing set. But overall indexing set is J. तो अगर कोई भी इंडेक्स अगर हम J minus I में लेंगे, तो वहां पे क्या होगा? वहां पे ये इंटरसेक्शन जो है वो इक्वल टू phi होगा. वो हमने यहाँ पे लिखा है. Also V है कि जो U intersection AI है, that will be phi if I belonging to I complement. I complement का मतलब J minus I. Okay, so U intersection AI closure is equal to 5 for I belonging to I complement. And this will also be for every I. This will be for every I in I complement. ये जो U intersection AI closure है. So that means can we conclude like that? कि अगर हमारा AI closure के साथ not equal to 5 for every I in I complement, then U intersection union AI closure will also be 5 for I belonging to I complement. Is it right from here to here? It is perfectly all right.
Yes, sir.
Yes, sir.
Yes. It is perfectly all right. क्योंकि ये सारे members के साथ अगर intersection empty है, इस union के साथ भी intersection empty होएगा. और अगर U intersection this set अगर आपका phi है, इसका मतलब क्या हुआ कि U is contained in this complement. ये तो वैसे भी आपको पता होगा ना कि अगर हम कह रहे हैं कि A intersection B phi है किसी भी सेट में, इसका मतलब क्या हुआ कि A is contained in B complement. ये तो आप फैक्ट कितनी बार यूज किया होगा आपने. क्योंकि U intersection this set A, so that's why U is contained in this complement. So I have called this as equation number 1. So this fact we will use. Okay, and here यहाँ पे हमारा indexing set क्या है? I complement के ऊपर है, ये आप ध्यान रखना. Okay, now here we have defined a set V. How we have defined V? U intersection. ये जैसे ऊपर की जो definition है, same pattern we have taken. Only ये कि यहाँ पे I complement में belong कर रहा है और here we are assuming that I belonging to I. Okay, so this we have defined. कि V is equal to U intersection. Okay, intersection AI bar हमें लग रहा है कि ये जो है ये हमें लग रहा है कि ये कॉम्प्लीमेंट बाहर रहेगा. I hope it will be like that. Okay, so let us see if there is any mistake, then I will get it. So V we have defined like that. So here V is open being an finite intersection of open sets. No, I think it is all right. Openness of V is all right.
Yes, sir.
Yes, क्योंकि AI क्लोजर क्लोज्ड है और कॉम्प्लीमेंट ओपन होता है और ये फाइनाइट कलेक्शन, ये I जो है हमारा फाइनाइट कलेक्शन है. Okay, this I is a finite collection, so that's why we have finite intersection. So V is open becomes the finite intersection of open sets. Okay, but the important thing is that कि X belonging to V, why X belonging to V? I think this I have explained here. कि एक तो ये है कि X तो आपको U में तो belong कर ही रहा है. Why X U में belong कर रहा है? Because U is an NVD of X. Okay, and X belonging to union AI closure complement. Why it is like that? ये हमने लिखा है ना कि X कहाँ बिलोंग कर रहा है. ये जो लिख रहा है ना, जो शुरू में लेके चल रहा है, यूनियन AI क्लोजर कॉम्प्लीमेंट में बिलोंग कर रहा है. ओके, तो X जो है कहाँ बिलोंग कर रहा था? यूनियन AI क्लोजर कॉम्प्लीमेंट में बिलोंग कर रहा है. इसका मतलब क्या होगा कि X जो है ये डिमॉर्गन्स लॉ से हमारे यूनियन का कॉम्प्लीमेंट क्या होता है? कॉम्प्लीमेंट का इंटरसेक्शन होता है. So X will belongs to intersection this AI closure I belongs to J. Okay, now since I is subset of J, so X will also belong to this set. Is it right? क्योंकि यहाँ पे आई जे का सबसेट है, तो ये जो इंटरसेक्शन होगा, so that this intersection is contained in ai complement I belongs to I. क्योंकि जब हम कलेक्शंस को छोटा करेंगे उसका इंटरसेक्शन लेंगे, तो जो ज्यादा सेट का कलेक्शन है वो उसमें बड़े वाले में कंटेंट, छोटे वाले में कंटेंट होएगा. It is like that, A intersection B intersection C will be contained in A intersection B. Is it right? Say yes or no?
Yes, sir.
Yes. Yes, I think it is perfectly alright. Here what we are getting, X belonging to this set, intersection AI closure I belongs to J. But since I is contained in J, तो ये जो intersection होगा वो further इस intersection में भी contained होएगा. Okay, intersection AI closure complement. So that's why X will also belongs to this one. अब आपका X already U में था, X जो है वो इस वाले सेट में भी आ गया, इसका मतलब X इसके इंटरसेक्शन में भी आ गया, इसका मतलब कि X V में भी आ गया. Okay, so that means what? If V is an open NVIDIA. Yes.
तो एक बार ये IJ वाला दोबारा एक्सप्लेन कर दो, इंटरसेक्शन पार्ट.
Sure. Oh, okay. Okay. Just 1 minute. I think I need to reopen. Okay. Is it all right कि X जो है वो U में belong करेगा? Because U is an open entity of X. Okay. अच्छा, इसके पहले हमने लिखा है कि हमने X कहाँ ले रखा है? X we have taken in this set union AI closure complement where I belongs to J. हमने शुरुआत तो यहीं से तो की थी.
Yes sir.
ठीक है, तो X इसमें आ गया, और यहाँ के बाद ये वाली जो इक्वालिटी है उसमें हमने डिमॉर्गन्स लॉ लगा दिया. ये जो यूनियन का कॉम्प्लीमेंट होता है वो क्या होता है? दैट इज द इंटरसेक्शन ऑफ द कॉम्प्लीमेंट्स. तो जो यूनियन एआई क्लोजर होल का जो कॉम्प्लीमेंट है वो किसके इक्वल होगा? वो इंटरसेक्शन एआई क्लोजर आई बिलोंग्स टू जे के इक्वल होएगा, जस्ट बाय द डिमॉर्गन्स लॉ, वेयर आई बिलोंग्स टू जे. और जे तो हमारा पूरा एंटायर कलेक्शन है ना, और आई क्या है? आई जो है वो जे का सब कलेक्शन है. तो हम कह रहे हैं कि ये जो इंटरसेक्शन एआई कॉम्प्लीमेंट आई वेरिंग ओवर जे है, दैट इज कंटेन्ड इन इंटरसेक्शन AI closure complement and I belongs to I. And to explain this last containment, what I told you, कि अगर सपोज कर ले कि अगर हमारे पास जैसे कोई भी कलेक्शन है, सपोज कर ले कि A1, A2, A3, A4 ऐसे हमें कलेक्शंस गिवन है. तो अगर आप इसमें अगर आपने सबका इंटरसेक्शन ले लिया, इंटरसेक्शन AI I varying from 1 to 4, तो ये जो इंटरसेक्शन होगा that will be contained in any intersection of 3 sets. अगर हम इसको इंटरसेक्शन AI ले ले और सपोज कर लो हमने I को 2 से 4 तक वेरी करा लिया, आई एम नॉट कन्विंस कि ये जो सबका इंटरसेक्शन है वो इस इंटरसेक्शन में कंटेंट रहेगा. you don't know कि जो A इंटरसेक्शन भी है वो A में कंटेंट है, वही फैक्ट तो यहाँ भी यूज हो रहा है.
Yes sir.
अगर हम 3 सेट का कलेक्शन ले लिए, A इंटरसेक्शन B इंटरसेक्शन C, so that is contained in A इंटरसेक्शन B. अगर हमारे पास 2 से ज्यादा सेट के कलेक्शंस है, तो ये वाली जो इंटरसेक्शन है दैट इज द इंटरसेक्शन ऑफ ऑल पॉसिबल सेट्स, जो हमारा क्लोजर कॉम्प्लीमेंट टाइप का है. और ये I क्या है? I is a smaller collection, so that's why this is contained in that. And we have started from here कि X जो है वो इस इंटरसेक्शन में, तो ये लार्जर वाले में तो होगा ही होगा क्योंकि ये इसमें कंटेंट है. तो फाइनली व्हाट वी हैव प्रूव्ड कि X belonging to U और X belonging to this intersection. So that's why we are saying that कि X will belong to V. And finally we can say that कि V is an open NVD of X. Is it not all right? Again you can ask if it is not clear to you.
It's so clear.
And can you explain that कि okay, so can you explain that कि why X belonging to this arbitrary intersection? because because this arbitrary intersection we are getting due to this De Morgan's law. And why X belonging to this? Because from where we have started this proof. From where we have started this proof. हमें इसी को तो दिखाना था ना, क्लोज है यूनियन AI क्लोजर I belongs to J. तो हमने इसको क्लोज दिखाने के लिए हमने क्या टारगेट फिक्स किया कि हमने इसका कॉम्प्लीमेंट ओपन प्रूफ करेंगे. तो हमने X कोई भी पॉइंट ले लिया इसके कॉम्प्लीमेंट में, यूनियन AI क्लोजर एंड कॉम्प्लीमेंट. तो यहाँ पे I क्या है? वेयर I वेरिंग ओवर J, जो इंडेक्सिंग सेट है. एंड दिस इज एक्चुअली व्हाट वी हैव टेकन. X जो है वो इस यूनियन में बिलोंग कर रहा है. और डी मॉर्गन्स लॉ से ये इंटरसेक्शन हो गया, और ये चूंकि I स्मॉलर कलेक्शन है इसलिए वो इसमें कंटेंट हो गया. इसका मतलब कि ऊपर वाले में कंटेंट हो गया इसमें. So that's why V is an open NBT of X. So again you are trying to go through it if you have doubt, if you ask. Okay. So now finally what we are getting, कि V is contained in this intersection. Intersection AI closure complement I belongs to I. Is it right? Why? Why it is like that? क्योंकि V क्या है? U. हाँ, V जो है इन दोनों का इंटरसेक्शन है. तो V तो U में भी कंटेंट करेगा और इसमें भी करेगा. Okay. So this is exactly what we have written. कि V जो है वो इंटरसेक्शन AI क्लोजर कॉम्प्लीमेंट में करेगा. तो अगेन अब डी मॉर्गन्स लॉ से फिर हम इस इक्वालिटी को ऐसे लिख सकते हैं, यूनियन AI क्लोजर I वेरिंग ओवर I एंड कॉम्प्लीमेंट. How we are getting this thing? By De Morgan's law, which you already know. अच्छा, again U is also contained in U, V is also contained in U, और U जो है वो इस सेट में कंटेंट है I कॉम्प्लीमेंट वाले में. ये जो ऊपर जो हमने दिखाया था, ये U कहाँ कॉम्प्लीमेंट कंटेंट है? यूनियन AI क्लोजर I वेरिंग ओवर दिस I कॉम्प्लीमेंट एंड कॉम्प्लीमेंट, जिसको हमने इक्वेशन 1 हमने कहा था. ओके. सो नाउ लुक केयरफुली, ये जो दो इक्वालिटीज है कि V जो है हमारा इसमें कंटेंट है यूनियन AI क्लोजर I वेरिंग ओवर I, एंड V कंटेंट इन यूनियन AI क्लोजर I वेरिंग ओवर I कॉम्प्लीमेंट. जब आप दोनों को कंबाइन करेंगे तो कैन वी से दैट कि V is contained in union AI closure I varying over I union I complement. क्योंकि ये दोनों में भी V में कंटेंट है, I में भी है और I complement में भी है. So we get like that. So that means what? कि X belonging to V, V is contained in, और I union I complement क्या है? यही तो आपका पूरा सेट J है. J को ही तो हमने दो पार्ट में डिवाइड किया था. J को ही तो हमने सबसेट लिया था ना, I को ही तो J का सबसेट लिया था, और I complement was what? J minus I. So that means I varying over J. Okay. So finally what we are getting? We are getting an open set V containing X, okay, and contained in this set. So we can say that कि ये वाली जो सेट है और X minus this is open in X. Why this is open in X? Because for every X belonging to this set, we are in position to get an open set V containing X and containing that. So that's why this is open. अब चूंकि कॉम्प्लीमेंट ओपन है, तो जब कॉम्प्लीमेंट हटा देंगे तो ये क्लोज हो जाएगा. ओके. सो फाइनली व्हाट वी हैव प्रूव कि अगर हमारे पास लोकली फाइनाइट कलेक्शन है, इफ वी हैव ए लोकली फाइनाइट कलेक्शन, ओके, देन द क्लोजर ऑफ द यूनियंस इज ए क्लोज सेट. सो दिस इज द रिजल्ट which we have proved, and we will use this result to, basically the purpose of this proposition is to prove this corollary. What is that? कि अगर हमारा X जो है कोई स्पेस है, and X is the union of this family of closed sets where each AI is closed. Each AI is closed. Okay. So now if this family is locally finite, then a map A from X to Y is continuous if and only if the restriction is continuous. So can you recall the remark of the previous corollary? What was the remark of the gluing lemma? पहले gluing lemma के स्टेटमेंट में तो हमने फाइनाइट कलेक्शन लिया कि ओपन है, ओपन हो या क्लोज्ड हो. अगर ये सारे रिस्ट्रिक्शंस कॉन्टिन्यूअस हैं, ओके, then the map is a continuous map. And if you recall, if we replace all by the open sets, okay, then still that statement is true. But if it is closed, then may or may not be. Okay, but here we have imposed a condition on that collection ये जो हमारा आर्बिट्रेरी कलेक्शन ऑफ क्लोज सेट्स है, अगर ये लोकली फाइनाइट हो जाए, then that statement is true. Is it all right? This statement is all right?
Yes, sir.
Okay. Okay. So now let us discuss the proof of this statement. It is not difficult at all. Okay. So वन में तो ये ऑब्वियस है कि अगर हमारा f जो है x से y में कंटिन्यूअस मैप है, तो f को ai पे रिस्ट्रिक्ट करेंगे तो कंटिन्यूअस होगा, क्योंकि अभी तक इसके पहले भी तो एक रिमार्क पढ़ा ना कि restriction of the continuous maps are continuous, so that's why it is all right. Important thing is another way. Okay, तो another way में चूंकि अब ये सारे closed है, if restricted to AIs are the continuous maps. Okay, I mean उसके उधर वाले hypothesis में जो हमें FI is given था, what was the FI? FI was nothing but the F restricted to AY. तो यहाँ पे जो F restricted to AI है, ये continuous map है हमें given है. Okay, and we have to prove that this map A from X to Y is continuous. चूंकि ये family of closed sets हमें given है और इस F को continuous prove करना है, तो we try to explain the same thing. ये जो हमारा inverse image of closed set is closed. Okay, so first of all we have an observation कि वैसे तो हमने लिखा है कि let F be the closed in Y, then F inverse of F जो है वो इसके equal होगा union of F inverse of F intersection AI. This one. But this equality is not only for closed set. This equality will be for any subset of Y. Not only this F. अगर हम Y का कोई भी subset ले लें, तो जो F inverse of suppose हमने F को O ले रखा है, तो जो F inverse of O होगा, that is nothing but the union of F inverse of O intersection A. Okay, so it is not equal. ये जो equality है, हमने जो equation वाला लिखा है, उसको हमने यहाँ explain भी किया है. Okay, it is just 2-3 line explanation. ये just right hand side को आप explain करें. The union of F inverse of F intersection AI. Okay, so it will be what? इस union में क्या होगा? That this union basically varies over AI. क्योंकि F inverse of F तो fix है, तो इसको हम ये equality लिख सकते हैं. This is nothing but equal to F inverse of F intersection union AI. और यूनियन AI क्या है? पूरा का पूरा x के इक्वल है, और चूंकि F इनवर्स ऑफ F x में कंटेंट है, तो F इनवर्स ऑफ F इंटरसेक्शन x क्या होगा? वो F इनवर्स ऑफ F के इक्वल होगा. तो we have this equality. So this equality basically we will use. Okay, but here our target is to prove this thing कि ये जो F x से y में है ये continuous मैप है. Okay. Okay. So now what we have been given? We have been given that कि जो F inverse of AI है from AI to Y, so they are the continuous maps. Okay. और F हमने क्या ले रखा है? कैपिटल F क्या ले रखा है? इस Y का क्लोज सबसेट ले रखा है. तो अगर ये कंटिन्यूअस है, इसका मतलब क्या हुआ कि इनवर्स इमेज ऑफ क्लोज सेट इज क्लोज्ड. तो जो F restricted to AI, yes, yes. Somebody saying anything? Yes. Someone said something? No. Is it all right what I am discussing? Say yes or no.
Yes, sir, all right.
Yes, sir.
Oh, okay. So just 3-4 lines remain, then we will stop for it. A map continuous है, तो inverse image of closed set will be closed. तो F हमने क्या ले रखा है? यहाँ का closed subset ले रखा है. तो F restricted to AI inverse of F will be closed in AI. Okay, and this F restricted to AI inverse F will be what? This is nothing but F inverse of F intersection AI. This you can easily verify if you are interested. Okay, so this set will be what? So this set is closed in AI. Okay, but here we have कि AI is closed in X. AI is closed in X. So that's why this set will be closed in X. Okay, now let us use that information कि ये जो family AIs है, so that is locally finite. But again here we have used a statement we have not stated earlier कि यहाँ पे AIs क्या है? Locally finite है. तो ये जो नई फैमिली है f इनवर्स ऑफ f इंटरसेक्शन ai, दिस विल आल्सो बी लोकली फाइनाइट. Are you getting what statement I am writing here? Look. Suppose we have been given this locally finite family. Locally finite family. And suppose bi we have taken, that is subset in ai for every I. Then are you convinced that with this collection bi is also locally finite? Are you convinced with this last two lines?
Yes.
ये हम कहते हैं हाँ, अगर ये लोकली फाइनाइट है इसका मतलब क्या हुआ कि अगर हमें फॉर एवरी x इन x देयर एग्जिस्ट एन ओपन एलवीडी यू जो कि इस एआई के केवल फाइनाइटली मीनिंग को ही इंटरसेक्ट करेगा. तो जब इसके फाइनाइटली मीनिंग करेगा तो ये जो नया कलेक्शन है बीआई इसके इनफाइनाइटली मीनिंग कैसे करेगा, क्योंकि ये सारे बीआई तो इन्हीं एआईज में कंटेंट है. Who is this? Okay, so now I hope you will be convinced कि ये जो AIs हैं ये जो AIs हैं ये लोकली फाइनाइट है. तो ये जो हमने एक नया सब कलेक्शन बना दिया कि F इनवर्स ऑफ F इंटरसेक्शन AI, so that will also be locally finite. अब अभी जो प्रोपोजिशन हमने यूज किया उसको प्रूफ के उसको यूज करेंगे. अब F इनवर्स ऑफ F इंटरसेक्शन AI अगर ये लोकली फाइनाइट है तो इनका क्लोजर का यूनियन लेंगे तो वो क्या होगा, दैट विल बी क्लोज्ड इन X. That will be closed in X. Union F inverse of F AI closure. और ऊपर अभी हमने क्या दिखाया ये जो F inverse of F intersection AI है ये क्या है, ये सारे क्या है X में क्लोज है. अगर ये क्लोज है तो इनका क्लोजर क्या होगा, इसके इक्वल होगा. Okay, so that means what, union F inverse of F intersection AI closure. So this is closed in X by the proposition, or this is equal to यूनियन F इनवर्स ऑफ F इंटरसेक्शन AI. Why? क्योंकि F इनवर्स ऑफ F इंटरसेक्शन AI क्लोज्ड है तो इसका क्लोजर इसके इक्वल हो जाएगा. और ये जो सेट है यही तो F इनवर्स ऑफ F के इक्वल है ऊपर जो भी हमने दिखाया. So F inverse of F is closed in X. So that's why this F is continuous, because finally what we have proved, the inverse image of closed set is closed. So now here I would like to stop here and next I will continue in next class. So if any
सर इससे पहले वाले पेज पे
okay sir.
यहाँ पे जहाँ आपने ये लिखा है that U intersection AI is empty, then you concluded that U intersection AI closure is empty. मतलब ये नहीं समझ आया कि अगर सबसेट के साथ है तो हम सुपरसेट के साथ कैसे बोल सकते हैं.
Okay. अच्छा
नहीं सर ये क्लियर है.
ये क्लियर है. और ये क्या है, ये नॉट इक्वल टू 5 है,
ये एम्प्टी है ना.
हाँ
ये तो एम्प्टी है ना. आल्सो वी हैव वाली स्टेटमेंट.
अच्छा ये नीचे वाले में कह रहे हो.
यस सर ये दो स्टेप्स जहाँ पे एम्प्टी से आपने कंक्लूड किया कि क्लोजर के साथ भी इंटरसेक्शन एम्प्टी होगा.
अच्छा ये वाले ओके 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 ठीक है ठीक है. I think this I have explained in this parenthesis. This is not I mean straightforward. कि अगर U intersection AI जो है अगर हमारा empty है तो in U intersection AI closure भी यहाँ पे empty होगा. So that we have explained in this parenthesis. Just 1 minute.
सर
हाँ
सर यहाँ पर AI क्लोजर इज इक्वल टू AI यूनियन AI डैश ऐसा करके एक्सपेंड करा है क्या आपने? फिर देख लेंगे कि इसमें नहीं होगा U इंटरसेक्शन AI डैश में, फिर दोनों में नहीं होगा, वहां से शायद करा है।
हाँ वो दैट इज एग्जैक्टली आई हैव ट्राइड टू एक्सप्लेन कि हमें U इंटरसेक्शन AI एम्प्टी है और हमें दिखाना है कि U इंटरसेक्शन AI क्लोजर भी एम्प्टी रहेगा। तो अगर AI क्लोजर में है तो वो कहाँ जा सकता है? वो U इंटरसेक्शन AI डैश में जा सकता है, जो AI का जो सेट ऑफ लिमिट पॉइंट्स है, क्योंकि जो हमारा AI क्लोजर है, so that is what? That is nothing but A union AI dash. Okay. So U intersection AI में तो कोई एलिमेंट है नहीं. So now I am going to explain कि जो U intersection AI dash है, इसमें भी कोई भी एलिमेंट नहीं है. So that is also empty. So I think that this I was trying to understood. कि अगर मान लीजिए कि Z जो है वो इसमें है, U intersection AI dash, तो इसका मतलब क्या हुआ कि ये Z जो है वो AI का लिमिट पॉइंट हो गया. Okay, so now how I was thinking that I have written that then U is a neighborhood of Z. Yes, U is a neighborhood of Z is all right, because in fact since U is open set, so U is neighborhood of each of its points. Okay, so U is also a neighborhood of Z. Okay, so now what we have? So now U intersection AI is equal to phi imply that Z cannot belong to its limit points, क्योंकि अगर U जो है वो अगर AI का लिमिट पॉइंट होगा तो उस पॉइंट को डिलीट करने के बाद ही इंटरसेक्शन नॉन एम्प्टी होना चाहिए. एक कॉन्ट्रडिक्शन आ गया. So that's why we are claiming that U intersection AI closure is empty. Is it right?
Yes sir.
Yes, sir.
Yes. So I think this explanation I have already written here. So one of your friend which asked कि अगर हमारा ये that is all right. ऊपर वाला तो obvious था, ये equal to हो गया, लेकिन equal to के लिए we need explanation, so that explanation I have given here. Any other doubt? Okay, so let us stop here. I will share these notes with your friend through which I am in contact through WhatsApp. Okay, and then I will continue this discussion in next class. And perhaps your house test is likely in the 3rd week of June. So I think date will be announced in next 2-3 days. And also, I had told you that I will take these 4 classes in online mode, and from next Tuesday I will take class in offline mode. But if you recall that we also have to adjust 2-3 classes due to that house or due to that ongoing, due to that main examination which held in last week or last to last week. So can I take those 2-3 classes on coming Saturday, Sunday, and the same time? So this you will think and you will tell me on Friday. If you will be interested, then I will take. Otherwise, I will take these 4 classes only. Okay. So anybody have any other doubt? Please ask.
Sir, do you know the syllabus for our in-house?
No. Right now, nobody knows, because there is, as you know, that there is a common syllabus in all the 5 sections, 4 in North Campus and 1 in South Campus. So I think whatever the course will be covered up to mid of June perhaps. So that will be the syllabus. So for that, it is not decided right now. And right now, nobody can tell you that what could be the syllabus. Okay. Do you have idea that how much course has been done in other sections? So on which basis one can predict? No. So let us wait and watch, and let us discuss quickly. Okay. Any other doubt? Okay. So let us stop here. We continue this discussion tomorrow at same time, 6 o'clock. Okay.
Thank you, sir.
Okay, sir.
Thank you, sir.
Okay.
Thank you.
Welcome.